All right. Our next session for the day is quite interesting. I had the opportunity to take a sneak peek into what it is, and I'm telling you, you do not want to miss this. First off, we have Biju Mookoni. A huge round of applause for Biju, everyone. Our very own technical writer, but he comes with 15 years of experience in shaping content and user experiences. And if you've seen Biju, you would know that he is part of multiple initiatives at Cisco, and this is one such. Okay, he's getting ready for the session. And one very important thing that I actually saw when I was reading his bio is, he said, I'm more interested in the why not more than the why. And that's a very important distinction, because the why not makes you take bold steps. The why not makes you take steps that have never been taken before. So huge round of applause again as we have Biju with us here today. All right, not yet, Ritu.
Okay.
So, all right.
I will start it off.
You want to introduce yourself?
No. Follow the leadership.
Okay. I don't know what was happening there. I think we have a lot of creative minds in Cisco who want to come up with their own introductions. But this time I want to introduce Ritu in a very different manner, because this woman is a powerhouse. Can we agree to it, everybody? She is a powerhouse. Her organization skills are top-notch. The very CDEx conference is a prime example of how good she is. And that is not all her forte, right? She extends this organization skills to content, to systems, and most importantly, to knowledge systems. And today she works as a documentation leader in Cisco Services Providers routing and data centers organization. And more importantly, a new role that she's taken up is that she's an AI native strategist. So can we please put our hands together and welcome both Ritu and Biju.
Thank you.
Thank you, Shishma. That was awesome. I did not expect that. Thank you, everyone. I mean, this is great. So how's everyone doing? Awesome. How are you finding the conference? Are you enjoying it? I'm going to come that side. I know I will not be at the, but I want to hear from this crowd. How are you enjoying the conference? I want energy. All right. So we've heard Scott and we heard Jason talk about intelligent content, right? So I am extremely excited to be talking to you today about enabling intelligent knowledge systems.
Just one second. Before you proceed, I just want to quickly get this audience's attention on a very, very important problem that someone we all know about is facing. And I think this audience may be able to solve the problem or not, but I think they should know about it. It's someone we know. This person is Harry Potter. And he's under attack. He's under attack from a dragon who's spewing fire. And he needs a specific spell to save him. His life is in danger. He summons the book of spells, and what does he get? It's a wall of text. What does he do? There is so much of information here. He doesn't know which specific spell is going to save him. He has no clue which spell to call out. His life is in danger. He needs the information right now. How can we help him?
Thank you, Vineet. That was awesome. You have defined our problem statement. So, the dreaded wall of text. Despite a lot of effort in content creation, our users often encounter what feels like a wall of text. Now imagine, somewhere in the world, it's 2:17 a.m. A hospital's network is down. The patient monitoring systems are flapping, clinical applications are timing out, doctors are nervous, and nurses are trying to get in touch with a network administrator. The network administrator is asking, What went wrong? How do I fix it right now? And what do they encounter? A wall of text. The information is there somewhere, but the answer does not surface. Imagine another scenario. A service provider is dealing with a nationwide outage. Millions are impacted. Leaders are asking for ETA. Social media accounts are blowing up with mean and nasty comments. The network engineer is not asking, how was this feature designed? They're asking, what went wrong? What changed? How do I fix it right now? And what does the system hand them? It hands them a document that optimized for reading, not knowledge that's optimized for action. And that's exactly the gap that we're going to be talking about today. So what's the problem? The problem is really not lack of content. There's a lot of content. The problem is that under pressure, our content does not behave like knowledge. You know, we spend a lot of time trying to optimize our content for correctness and for accuracy, and that's good. We should be doing that. But do you think we have optimized our content for urgency, for problem solving, for time to resolution? Yes? We have not. So under such high-stake moments, the cost of a wall of text is not mere inconvenience. It is risk, it's downtime, it is loss of credibility, and maybe even lives. Okay, maybe that's a little too far-fetched, but you get the gist, right? And that's where our vision comes in. Our vision is intelligent, connected information. A user experience that's designed not just for mere browsing, but to help users under pressure. So instead of forcing our users to, hunt for information and then read and then scan, we want to transform their experience into one of intelligent and effortless search and discovery. So that when users come looking for information about a specific issue, we don't just trap them on a single page of document. We move them forward. We move them forward from a concept to tasks, to troubleshooting, to white papers, even notes from a support case, maybe. Because problem solving is never linear, right? And this is what moves us beyond simple keyword searches to a system that actually understands the meaning and context of the information. And that's how we are able to provide them with a richer, more intuitive experience, especially when it matters the most. So the core enablers of this vision, there are 3 core enablers: taxonomy, ontology, and knowledge graph. And how many of us have at least heard of these terms? Okay, quite a few. And you also probably know what these means, what they mean. So taxonomy, it's a classification, hierarchical classification system. Ontology is a model. It defines meanings and relationships. And knowledge graph is a working system. So let's dive a little bit deeper into what these terms mean. So taxonomy, like I said, is a very simple hierarchical classification system. It organizes the concepts or entities into simple parent-child relationships. Basically, it tells us who or what something is. So let's make this a little more concrete. Let's ask, who is Harry Potter? Since we have to save him, right? And the answer is Harry Potter is a fictional character. So this straightforward answer, how did I get it? I got it because the taxonomy has been arranged such in a parent-child relationship. But notice what taxonomy does not tell me, and that's important, right? It does not tell me what Harry Potter does. It does not tell me why Harry Potter is even important to the story. And it does not tell me how Harry Potter is related to the dragon. I have no idea without any context if I should be rooting for Harry Potter or for the dragon. So taxonomy provides structure, but only at the identity level. It does not provide any meanings. And when I have to understand roles and relationships, I need something more. I need ontology. I need a model that understands meanings and relationships. And ontology is what takes things a step further. So what is ontology? It's a rich model of concepts, their properties, and their relationships. Unlike taxonomy, it's not just restricted or limited to hierarchy, but it also includes associations, attributes, constraints, and all the rules that govern these relationships. So how does ontology, so again, I said ontology is a model. Let's see how it's modeled. So drawing your attention to what's in the box, and I'll give you a second to just read what's there. Ontology has not only classified an entity. Now, entity in this case is student. It has classified the entity called student, but it has gone beyond that. And it is modeling that entity in the context of the world around it. What is the world here? It's the father, mother, school, bird, device, whatever. And this is what brings meaning and intelligence to the system. Let me clarify that. Let me just dive a little deeper. Ontology has defined the entity, which is the student. It has defined the attributes of that entity. Student is a wizard. And it has defined how it relates to other entities. What I'm more interested in is in the third last thing. Student fights against evil. Now I know I have to root for Harry because I have that relationship. So at this point, I have a very powerful model, but it's still a model. To make this operational, to turn it into something that a system understands, I need something more. I need a knowledge graph. Because what does knowledge graph do? It connects a model to a real world data. So we've spoken about structure, which is taxonomy. We've spoken about meaning, which is ontology. Knowledge graph binds all of this to the real world. So let's look at what the definition of knowledge graph is. It is basically a data structure that connects all of this information such that machines, which is AI assistants, bots, AI agents, can answer questions like a human does. So let's get back to our familiar example of who is Harry Potter. And this time, I'm not going to ask a system, I'm going to ask Google. I'm going to Google for who is Harry Potter. Now, when I do that, Google doesn't give me a bunch of links. It gives me something like this. Everyone's familiar with how Google presents stuff, right? Now, if you pay attention, when I do that, Google has given me the entire bio of Harry Potter. It tells me who Harry Potter is, who's the creator, the number of books, the number of movies, the actors, how are the actors related. It gives me a whole bunch of information. And that is knowledge graph in action. And again, how did this happen? Let's again look at the text in the box. So what you see here and what's exactly under the hood is something called as RDF triples. Resource Description Framework triples. A triple is nothing but three things. And in this case, its subject, predicate or verb, and an object. So what is it saying here? It's telling me Harry Potter is a wizard. Harry Potter studied at Hogwarts. Harry Potter is the son of blah blah. Now, these are very tiny, simple statements. But when I connect thousands or even millions of such statements, what I get is a knowledge graph. So when I Google for who is Harry Potter, Google traverses a graph that is built on RDF triples. And that, my friends, is the intelligent knowledge system. My thing is done. So we don't really need more content. We only need connected, machine understandable knowledge. Okay, this is a fair question. I understand this is getting a little abstract. So let's take a step back. Let's look at something more simpler. If I told you RDF triples are all around us and that nature uses relationships extensively, would you agree with me? Yes, no, maybe. Yeah, maybe. Yeah. Okay, so what I'm going to show you next is a very small microcosm of what exists in nature. And this is what I called nature's knowledge graph or nature's K graph. Now, even before I talk to you about anything on this slide, your brain already understands what's going on, right? It's so simple. There are 4 entities. There's an oak that's classified as a tree, the buffalo grass that's classified as a grass, rabbit, that's a herbivore, and a fox that's a carnivore. That is taxonomy for you. But what makes this scene or this image more meaningful is the relationships between these entities. Yeah? Rabbit climbs the oak. Rabbit is eating the grass, or the rabbit is eating the carrot. The fox is looking at the rabbit, and it's most likely going to eat the rabbit.
Almost. This last slide.
And that is, does that feel technical to you? Yeah, people from there? It doesn't, because it isn't. And that is exactly how knowledge graphs are. Now, I can express all of these relationships as RDF triples. Rabbit climbs oak. Rabbit eats grass. Rabbit eats carrot. Fox eats rabbit. Yeah? Now, again, these are, very simple, tiny statements. But when I combine them together, I get a system that understands the world. And that is exactly how intelligent knowledge systems work. Only at scale, in a specific domain, and with well-defined connections. And I just want to introduce one more concept. I know there's too many concepts, but I also want to bring in another concept, and that's called controlled vocabulary. Now, if you noticed, I consistently used the verb eats. I did not say feeds on or consumes or devours, because as humans, we understand the context. We understand that these mean the same thing, but machines don't. And I know I said that humans understand, but do we really look at the world around us? We speak different languages. When 2 people speak different languages, and when they even use the same words with a different context, there's misunderstanding, there's argument. And when machines encounter such ambiguity, they don't argue, they hallucinate. So I would say that controlled vocabulary is the key to a successful relationship between humans and between humans and machines. And with that background, I'd like to call upon our relationship counselor, Biju Mookoni.
Aye, Captain. Now that you have conferred me with that title, let me break up some facts. Okay. Good morning, everybody. Sorry, good afternoon, everybody. Hello, people on the bridge, and hello, everybody on the different time zone. So I hope I'm audible. Thank you. This is a good day to click. I'm keeping myself on the timer. I talk a lot, is what they say. So, okay, I know food is around you can smell food around the corners, so I'll keep it short and interesting, okay, for all of you. So, okay, coming back to the Fox. Let's move on. It's got enough footage. Okay, so RDF triples, right? So Ritu helped us Star Trek into a whole new galaxy of taxonomy, ontologies, knowledge graphs, and RDF triples. Let's hover around the brightest star in this galaxy, which is not Harry Potter, it is RDF triples, sorry Potter fans. And so let's look at how IKS can probably help Harry come out of this pickle with the dragon. So I'm going to ask you very simple. I'm going to show you a snippet of a dense web page, just a snippet. The usual works, the paragraphs, wall of words, and how many types, or kind of how, if you can visually imagine in different types, how you see that piece of content. So that's your wall of words, the typical wall of words, right? So now my question is pretty simple. In how many different visual types can you see this content in your head, right? So probably it's you can redesign it as a list. You probably can think of it as, probably chunk it a little bit more, probably give it more titles, maybe a table. Or at the best, if you take a few notches higher, it might be a good-looking illustration. But it's still a wall of information, right? Now watch this. So now, suddenly, this content has transformed into things, entities, which are interconnected to each other. And if you look at it very closely, these interconnections, these connections have labels. Now, those are the relationships. And that's the shift in thinking which we are trying to bring with RDF triples. See your content or document as data, right? From text to connections, and from connections to relationships. So at this point, if you're wondering, hey, I want to do this for my content, a friendly reminder, this is what we exactly unravel in the IKS workshop. So please attend that. So now, but the ambiguity around RDF triples still remains, right? So what is RDF triple? RDF triple is the fundamental building block of resource description framework. It's a W3 standard used to store, represent, and exchange information on the semantic web. So it's a machine-readable statement which consists of 3 parts and codifies a single fact or relationship. Let's peel the onion a bit more. So what exactly does resource description framework mean? Pretty simple. It might sound daunting, but it's pretty literal. Resource is nothing but just a thing. It could be a feature, platform, wizard, spell, dragon. A description is a fact about that thing. Harry is a wizard. Wizard uses spell. It tells you something more about the resource. A framework is just, a method of keeping these facts unambiguous. It's a framework to ensure that there is consistency in the way we represent all this information so machines can read it well. So what exactly does RDF triple constitute? It constitutes 3 parts. That is the subject, verb, or as we call it, predicate, and the object. The subject and the object are also called nodes or entities in the typical classical knowledge graph scenario, right? So if you look at it, these 3 form a meaning. Now the meaning is nodes plus relationships. So at this point, I want you to think about how it is semantic middleware, right? So RDF triples actually sit very quietly as a semantic middleware between the human written content and the AI systems that consume it, right? So it basically converts all the structured, unstructured, semi-structured content into verifiable facts for the AI systems. And I would also like to say that imagine this, if these same RDF triples are extracted from content which is written with clear guidelines, writing guidelines, which has clear structure, which has clear terminology, standard terminology, and clear relationships. Just imagine the nature of these RDF triples which are extracted from this content. It'll be more clean, more precise, and it'll be much more powerful. So basically, why it matters. One triple is just clarity. Two triples could be helpful, but think about all the millions of these triples coming together, and that becomes reasoning power for the AI system. So you got same content. We are not adding any content. We are just adding more context. So now if I go back to the same content, which is now represented as a graph, and if at this stage you want to know, how do I go about generating these RDF triples and curating it? That's exactly what we unravel in the IKS workshop. Okay, so moving on. Let me ask you before I move on. Now that we have, spoken about uncovered RDF triples in its native format, right? Which aspect of human biology or just general biology can you equate it with? Any guesses? Absolutely. Were you in the sitting? Okay. Okay. So could you explain why? Why do you pick up on the DNA? Okay, that's a good one. So as rightly said, we look at it also as the DNA. RDF triples are to AI what DNA is to biology, right? Now think about it. You can unspool all the chromosomes into its constituent DNA, right? And so RDF triples also does that. What it does is it destructures or decomposes your content into individual RDF triples, which AI systems can compile, reconstruct information again. So at this point, let me be very clear, RDF triples are not just raw data. They are tools to enable operational atomicity for the AI systems. That's the word that I will use, operational atomicity. Just like DNAs are operational atomicity or work at the operational atomicity level to recreate your cells, right? So, oh, okay. So we need to go back to Hogwarts. Something is messed up at Hogwarts. We have been talking enough about RDF triples. I think Harry needs help. And looks like the AI systems which we provided Harry with just looks good on paper, right? I'm not sure if he has been able to find the precise spell. So let's get back to Hogwarts and see what's happening there. Oops, okay. So looks like the spell didn't work. Okay, let's do an analysis of why it didn't work. Harry's AI systems looks good on paper. We, kind of gave him with just about everything. The AI systems, knowledge graphs, ontologies, taxonomies, and still something went wrong. So AI search probably failed to generate the right spell for Harry to vanquish the dragon. And why did that happen? That happened probably because AI systems right now don't have enough context to find the right spell in this scenario for Harry. We all know, we have faced that whenever there is a context riff, AI tries to fill in something, pleases, and gives you a hallucinated response. And that's why probably the dragon is still clapping. Now, why did that happen? We gave it a proper working knowledge graph system. It still failed, right? That's because the knowledge graph is underspecified. What do we mean by being underspecified? And that means the RDF triples, which form those, which constitute that knowledge graph, are inconsistent. What does that mean? Verbs were uncontrolled. Whatever verbs we have used to define the relationships between entities were not controlled. And that means, which brings us to the main thing here, right? The magic word is controlled vocabulary. Controlled vocabulary is the magic word, and that's what we will be looking at the next segment. And like rightly put in by Wayne Knight in this giant of a movie, that we need the magic word.
You didn't say the magic word.
Any guesses? It belongs to which movie? If they wouldn't have been extinct, you would have got a dinosaur. So moving on to controlled vocabulary. So it's not just any spell. The right spell is going to work, right? One idea, one agreed word with one meaning, same verb, same outcome. So we need to make sure that controlled vocabulary locks in these verbs to ensure humans, AI systems, just about everything infer or refer to that specific verb in the same manner, and there is no context drift. So if I were to give you some examples, hey, we are playing Team Harry, by the way, not Team Dragon. So what works for Team Harry is Harry casts spell targets dragon, spell protects Harry, and spell harms dragon. What will break the system is what you're going to see now, right? Spell targets dragon and spell protects dragon, right? So you have got two scenarios unfolding here. You have got the same verb. You can use the same verb to break the system. When will it break the system? If you use the same verb to connect two different kind of entities. Scenario number 2, you use two different verbs to connect the same kind of entities, right? So there are two scenarios we need to look at. Moving on. Now, light years away from Hogwarts, let's get back to reality, technical documentation, Netflix, blah, blah, blah. So product documentation, right? Feature X is supported on product Y versus Feature X is enabled on product Y. These are not equal. Anybody wants to take a stab at it? Not at me. You know, what's the difference between supported on and enabled on in terms of product documentation? Hey, you guys do it all day in, day out. Come on. Anybody? I'm on the timer, by the way. Yes, Harika. Harika, Hari.
Hi.
Okay.
So I guess supported would be can something, can you deploy A on B? Enabled would be A is active on B.
Absolutely. Right. So as we see it, feature X is supported on product Y means the support is enabled, right, by the manufacturer. Feature X is enabled probably could mean that it is enabled by default. You need not explicitly configure it when the box comes, right? So the same thing if anybody wants to go for, you know, like Smith viewed Back to the Future versus Smith completed Back to the Future. Now, these could be hypothetical, verbs that I'm using here to explain. But Netflix is one of the biggest users of knowledge graphs, by the way, just like Amazon is. So Smith viewed could be something like, hey, I viewed just 30 seconds or probably 30 minutes of the movie versus completed, which completely changes the meaning, the context, the relationship, right? Smith liked Back to the Future versus Smith rated Back to the Future. This one I personally like. So if anybody wants to go for it, again, I know I'm asking a lot of questions, sorry. Yeah, please.
Smith liked means he liked watching the movie, and rated means he is recommending the movie to someone. I mean, he's telling that it's really good. Go and watch it.
Right. On the same lines, like means, okay, it's a binary signal. Thumbs up, thumbs down, right? The usual stuff. Smith rated are more in numbers, 1 star, 2 star, up till 4 star, so 5 star, right? So that's a more explicit signal, and we can use it as a metadata for the systems, the AI systems, right? Anything below 3, the person didn't like it. Anything above 3, the person liked it. So it's not binary, it's more explicit, right? So now why does it matter? The control vocabulary. Now control vocabulary in the world of IKS, I would say control vocabulary along with RDF triples are the first class citizens, right? They need to be there or else the system fails. And kind of control vocabulary make sure that we are weaving in a layer of determinism in this otherwise probabilistic nature of AI. And that's not going to change. It is going to be probabilistic every time. You may refine it further, but that's what we are trying to achieve here. That's the shift. To weave in a layer of determinism into the probabilistic nature of AI. Okay, so I want you to pause and take a look at the next slide. Some good-looking folks there. Please don't put it in the feedback QR. Feedback. So what is happening here, right? So intelligent knowledge systems, IKS, is not a tool. It's not a single tool. It's a system, as the name says it, right? These, you're like, for everybody is bringing something to the table. Somebody's throwing in taxonomy, ontologies, knowledge graphs, unstructured source content, REF triples, AI, right? So these are not operational silos. They have to work in together to get Harry the magic spell, right? So taxonomy brings order, ontology adds meaning, REF triples structure the truth, that is, our verified facts. Control vocabulary fixes the verbs, and knowledge graphs connects those facts. And AI accelerates the assembly. That is critical at this time because that's what we are heading toward. Everything has to work at a faster pace, and that's where AI comes in, right? So, well, the expression of Harry says it all. That was prompt. So moving on, now we have got the right spell for Harry. Now, back to the context. This is where we started. Harry was facing at a wall of words. There was, kind of lot of content, but not enough context. And so we gave him a lot of context with the same content represented in a different form. We weaved in a little bit of determinism with the probabilistic nature of AI. So now we have RDF triples, which hard-code these verifiable truths. And yes, when I say curate these verifiable truths, as of now, there is human in the loop involved, right? So truths are expressed as RDF triples. All of these connect in millions and millions to form these knowledge graph pathways, which is very steeped in context. That's what we look. We need context. So the shift here is context, or AI systems stop inferring information. Rather, they start discovering information. That's the shift we are trying to make here. And so, well, he finally is able to vanquish the dragon, but he has a question for all of you. So that's the shift we are trying to achieve here, looking at document as data, looking at unstructured, structured, semi-structured context or content as, lot of relationships to build the context. And so if you're, kind of probably feeling overwhelmed or slightly underwhelmed, I would say, with all the events that unfolded at Hogwarts, and if you really want to know how we pull it in the lab, please come see us. That's exactly what we are, kind of going to demystify in the IKS workshop. And we have gamified the RDF triples. So if you visit the booth, you will get to play the RDF triples game for yourself and understand how, if you change a verb, how it changes context. So more context, more power to context. This is what we have as offering. With this, we open the floor for your questions. Thank you. Is it working?
Check. Hello. Check. Yeah. You showed the RDF triples, how it works and how it makes it easier for AI systems. But to develop this ontology and the RDF triples, can we leverage AI?
You want to take that?
We already have.
Okay.
So we already have a prompt in place that can help you generate the RDF triples. Again, there's a workshop for that. But yeah, that makes it very simple. So if you, I don't know if you're aware, but earlier we would have ontologists who would go through your data to come up with these connections. Now with AI, it's very simple. We have a prompt, and it just takes about 10 minutes.
Maybe lesser.
Yeah, maybe less than 5 minutes to generate RDF triples for a document that's even hundreds of pages long. But what is required from your end is verification and validation. That AI cannot do for you.
To add to what Ritu said, like I mentioned, right, that's what brings in the layer of determinism, the deterministic patterns. We hard code. I mean, obviously AI will spin that out for you, right? But things could be wrong because again, you can't kill probability with another probability. You have to bring in a layer of determinism to kill probability or offset it to a certain extent. And that's why that's how we are planning to keep the AI systems grounded. And that's how we are planning to keep it, kind of making sure that there's no context drift. Yes. Oh, the mic.
Your control vocabularies, is that managed with AI or do you have a human auditing that? I'll give you an example. You have spells protect Harry and you have spells protect the dragon, right? You might also have an instance in the content that says dragon spells danger, right? Where the context has become a verb. The content has become a verb, right? So how do you manage that vocabulary to say that spells is the word that you replace with means?
Okay.
Yeah.
That's a good question.
Is that going to be handled by AI or will you have a human managing the control of the controlled vocabulary?
Want to go for it?
So for now, in our product line, when we have developed this prompt, because we know our content so well, we have a list of verbs or predicates already available. As we move on to different products, now ours is a CLI-based product. We go to cloud-based products, GUI products. They would have their own, in the example that you cited, somebody's noun could be a verb. So we have a governance board that will review. So if someone comes and says, I now want spell as an added predicate in this list, and we will review it. Is it really required? Does something else measure up to it? And if it doesn't, then we will include it in the prompt as an added predicate.
Far more extensive than Acrolinx is designed to handle.
Oh, yes. Yes.
Right.
But there is.
Do you want to talk about the governance board? Yeah, right.
Yeah. So I mean, the context matters, right? If it's a GUI-based product or a cloud-based product or whatever. So again, people will come back to us and say, no, I need this. And this is the context for the verb. And if it goes through, we add that to the prompt.
So in this
And it's very human driven. It's not AI driven.
In this setting, you have limited context. Limited
Yeah. Yeah.
Right.
Right.
Thank you for the question.
So what is the effort? Oh, somebody's asking the question. You can take your question.
Yeah, great session, Ritu and Biju. So I have two questions. One from the product perspective. So you are saying that, we will have a controlled vocabulary. And at Cisco, we have several products and, maybe one product might say add, another product might say create. One might say remove, the other might say delete. So how are we going to handle, such a scenario? And the second one is from the customer perspective. Now we are going to get trained, using IKS, but an old timer will always ask supports or, may not look for enables. So may always search for product A supports product B versus, product A enables product B. So how are we going to handle such scenarios? Have you thought about that?
I want to add to that is
Thank you.
Right.
So maybe if Stella had a style guide that differs from yours, then you would have to address this.
Right. Yeah.
Done.
I will just add to him as well to the same question. What is the kind of effort that is going into adding all of these changes? Because in my mind, I'm thinking that we are sort of retraining the model. So what is the effort, human-wise, time-wise, cost-wise, that is going into it?
You may want to talk about the governance board. I can take the next leg of the question, which is about the effort.
So, okay, sorry, now I completely forgot. What was your question again, Sheila?
product perspective.
Yeah, right. Correct. So, exactly. So, as writers, as content creators, we now need to think, does add and create mean the same thing?
Standardize.
I mean, targets, and give me an example. I mean, there are multiple things. Like, I'll go back to the example that I cited, right? Eats versus consumes or feeds on. As a group, we need to decide. See, if we can go as far as we want, right? We are only confusing the system. So exactly. So as content creators or context engineers now, we need to go back to our products and tell them that, hey, this is going to come into AI systems. Do we want to confuse the systems? And again, we can have that dialogue. But this is something we need to consciously think about and work towards.
So that's a great question. And I just have one more layer to add there. Imagine this. You don't have to do much to the content. What about the systems in the backend creates an alternate label and handles that?
They're refactoring stuff into
Right.
Yeah.
So even if you write it that way, some other teams that write in some other way, in the backend, the system connects the dots. Why not? Yes, please.
Quickly to Sheila's point, it's a great point. The GUIs can still say what they want, right? We're not trying to change the product here.
Correct.
What we're trying to change is how the machine understands it, right? So we'll have a layer of RDF triples. RDF triples are not getting connected to the product or the content. In an AI workflow, there will be APIs will come back and forth and pick up that content. We'll have hooks in the content, but we'll also have hooks and contextual, hooks to where it's published. Those connections is something that our AI-rich metadata will also define. So metadata also plays a big role in this. We will not go and change because, hey, we decided, no, we're going to say only enter, we're not going to use any other word. That's not going to happen. How it interprets it. And that's how, if you see all AI systems work, right? You may have a spelling mistake in your query. You may say one thing and mean the other thing, but it'll answer you based on what context it has. That context building is what we are trying to do with RDF triples, and we will achieve that with an AI-rich metadata, which will form a layer. We're not touching the authoring system. We're neither touching the product. It's an impossible task. That's not going to happen. To Eddie's question as well, right? You have an acquisition tomorrow, and we quickly want to move them here. We will have to add that layer. Here's a layer. We will make those connections for you. Good to have structured content. We have CTWG, we have Cisco writing guideline to make it AI ready. Good to have that in place and use AI to maybe quickly generate it and then make it ready. But this is what we'll do. We'll have multiple layers to make these connections. It's not one silo. There'll be multiple repositories through which this AI will quickly go and pick up stuff.
Basically, the controlled vocabularies in the metadata. The controlled vocabularies in the metadata, it does not affect the word used in the document, right?
No, it's not. So like Vineet rightly said, right? I mean, we are fixing our content. We are, and the way we are developing the prompts, we will say that there are alternate usages of the same word, so that we bind the system in that framework. And to answer your question, what is the cost, right? Well, there is some amount of, okay, so the effort is in the validation of the RDF triples. But look at the outcome. When users search for information, are they 100% finding what they need? They're not. We're trying to fix that issue, right? Especially with AI systems that hallucinate. So so there is some effort there. In terms of infrastructure, yes, knowledge graphs are required. Graph RAG models are required.
Graph RAG models are required, yeah.
And compute power is required because as you build these graphs, they have to hop on to multiple nodes to get that information. So there is some compute power required. So there is a cost there.
There is one question in the bridge. And it says that do most documentation teams already have parts of the system without realizing it? And for example, teams using data already have structured topics, metadata, and reos. Are those the early building blocks of IKS?
Okay, so we planned or we designed IKS as a authoring tool agnostic system, right? So, hey, things will get published anyway, right? So it's better to source the published content rather than the source content. I understand there are two ways of looking at it. You have source content also, data where you can extract metadata, rich metadata. And the reason why we wanted to keep it tool agnostic is because when there are changes, when you want to move from data to markdown or vice versa, right? It should not impact, because end of the day, we are looking at context. If there are any other ways of enriching the RDF triples using metadata, yes, we are looking at that as well in terms of layering, right? So this is a semantic middleware. It doesn't mean it's just one layer. We can still break it into multiple layers. That's the, that's the magic we are trying to pull here, that how to break one layer into multiple layers so that it's not disjointed, right? So if there's some changes which is coming our way, it can still accommodate those changes, because the nature of IKS is built to keep it agnostic, as simple as that.
Yeah, so I was just going to respond to her question. Forgive me for that. So in terms of cost, right, you have to look at cost as an investment, right? You can choose to travel in a non-AC cab, or you can land up like a lump of molten chocolate, or you can use an AC cab, right? So the difference between that cost of an AC cab and a non-AC cab is your investment. When it comes to AI, we're looking at turning everyone into Harry Potter to have magical, productivity enhancements in your output. That comes with a cost. It comes with hallucinations. This helps minimize or eliminate hallucinations. So this becomes a necessary step to using AI successfully. And the payoff is your return on investment.
ROI, correct. Thank you.
Thank you.
Yes, we have tested extensively.
We have tested those extensively.
So that's what we will try to uncover in the IKS work.
I'm so glad people are not hungry.
All right, if we have more questions,
Okay.
we will take them up during our networking and lunchtime. We want to ensure that we end on time. All right, thank you so much, Ritu and Biju. A huge round of applause for them.
Thank you all.